Alright, so the first thing we've got is what is a function? So, you want to give me your definition? Yeah, go ahead.
A function is where each x input has only one
Yes.
y input.
Yes. So there are two ways to think about a function, and so let's think about it. Let's kind of go in two different directions here. I'm going to start with what Cole said, because that's super important, that each x value, bless you, each x value matches to only one y value. So in the warm-up, that happened in one of the cases, but not the other, because we had a doubling up of what x was equal to. So on the second problem from the warm-up today, that one would not have been a function, but the first one would have been. So no doubling up in terms of the x value. So each x matches one y. We have a special name for this. We call it 1, 2, 1. They are 1 to 1, meaning each one x is matched to one y. It's not matched to multiple y's. Now, have you heard of the vertical line test before?
Yes.
Okay. That's another way to tell something is a function, is that it passes the vertical line test. Now that gets a little obnoxious to write out each time, right? So you can write VLT, and I am fine with VLT for vertical line test. Function notation is something that looks a little trickier than your regular notation. Function notation is when we write something like this, where we've got f of x. So x is a function of x. Now, you can use different letters. 99.9% of the time, this is an x. But this could be a different letter. You could name your function other than f. Again, we usually call them f because the word function starts with f. But we could have g of x or h of x, or we could pick another letter. But like I said, 99.9% of the time for this unit, you're going to see this being an x. Okay, how to identify a function. So it depends on what you're given as to how you're going to identify it. So let's start with a table. And table and mapping are kind of two different things to me, so I'm going to show you them as two different things. So let's start with table. So if you have an XY chart, let's say you have 1, 2, and 3 being plugged in. Let's say you get out 4, 7, and 12. So is this a function? Yes, this one would be a function. How do I know? Because each x only occurs once. It's not occurring more than once. So you're looking at the x column and seeing if you have something that comes up more than once. So let me show you a no. So that's a yes. What does a no look like? The no, like I said, looks like the second one from the warm-up today. So if I had 1 matched with 3, and then I also had 1 matched with 5, and then 2 matched with 4, and then 3 matched with 7. Do you see how the 1 doubles up here? That's problematic, and that's what makes this one a no. So this one is a yes, this one is a no. So again, you're looking for your x value to double up. Y values can double up, and that's fine. X values cannot. And again, the reason being is when you think about it graphically, that it wouldn't pass the vertical line test. All right, so mapping is going to be kind of similar. Let's do a yes and a no. Again, you can write domain and range, or you can write x and y. It's up to you. Let's say you have 1, 2, and 3. Let's just use the same example. Mapped with 4, 5, and 12. So we've got 1 matched to 4, 2 matched to 5, 3 matched to 12. Everything is good and happy. Yay. That's a yes. The other one, yay. The other one, not as much. So the other one, we had 1, 2, and 3. We had 3, 5, 4, and also 7. So the 1 was matched to 3 and also to 5. So if you have something from the column on the left going two different directions, that's not one-to-one, right? That's going two places. So that's why we would say that, no, this is not a function. We had 2 mapped to 4, and then we had 3 mapped to 7.
It's only just two values, right? So
2 y values is okay. So here's another one that would be a yes. Let's look at one more yes situation. If you had 1 matched to 4, 2 matched to 5, 3 matched to 7, and 4 matched to 5 again, this is still a yes. Okay, so you can double up on y values, you can't double up on x's. And again, that's, when you think about it graphically, if you were to graph it, one would be a function because of the vertical line test, one wouldn't. So the graphs, let's look at a yes and a no for the graphs. So a yes and a no in terms of being a function. So let's see, we could have something like this. This could be like a cubic or a quintic function. So odd functions kind of look like this, where they go up and down and back up again. Do you see how if I pass vertical lines through it, none of them will touch more than once? So that's how I know that that is, yes, a function. This one would be a no. So again, you're thinking about passing vertical lines through it. Like the vertical line test is literally what it says it is what it is. You're going to pass vertical lines through and see how many times they touch. If it only touches once, then it's a function. If it touches more than once at any spot, then it's not a function. So do you see how this one touches 1, 2? So if any of them touch more than once, then no, it's not a function. Okay? Evaluating is the last thing I kind of want to talk about before we get into some examples. Evaluating is what it sounds like as well. It's when you're finding the value of something. So let's say you have something in function notation and it's f of x equals 3x plus 1. Let's pretend that's our function. And let's say I want you to evaluate at x equals 5. All that means is that I'm going to take a 5 and plug it in. So instead of f of x, I'm going to do f of 5. So in place of the x, now I put a 5. And remember, if the 3 and the x were right next to each other, that's multiplication. So you still preserve that multiplication. If I use my order of operations, what should I do first? Multiply. So 15 plus 1, 16 overall. So again, order of operations is still significant because if I had added first, I would have gotten 6, and 6 times 3 is 18. That doesn't work, right? You've got to make sure you still use order of operations at all times. So if you're asked to evaluate, that means they're going to give you a value and you just plug it in for x. And again, 99% of the time it's going to be x. All right, ready for some examples? Okay. Decide if it's a function. Decide whether each relation is a function. So we talked about relations and how relations are a relationship between two different numbers, like an x and a y being coordinated together. So we're either going to say it's a relation, just a relation, or it's also a function on top of that, more specifically. So, is the first one a function? We're looking for doubling up of x's. Is it a function? Yes. My y's double up, but is that okay? Yes. Number 2. Do I have any x's that are connected to more than one thing? Yes, the 0, right? That's problematic. So no, this is not a function. Number 3. Again, see how we do a little bit different tests with each one? Right? It's not super different, but just a little. If I run vertical lines through number 3, does it pass the vertical line test? Sure does. So this one's a yes, a no, and a yes. Okay, flip, we've got a couple more problems we're going to do. Is everybody good with the front side? Yes. All right. Some more deciding whether or not they're functions. Okay, take a look at 4. We've got a table. What do you think?
Yes.
Yes, because do I have any x's that pop up more than once? No. So this is a yes. Okay. Ooh, what about 5? Look at your point. No, because if I draw a vertical line down through my y-axis, how many points do I encounter? Oh, you didn't see it? That's why. Yep. So this one is a no because of that sneaky point that's hiding down in the negative land. Okay. Function notation. So this is a little bit trickier than the one we just talked about because you need to figure out which one to plug it into. So if it says f at 7, I'm going to plug it into f of x. If it says g at something, I'm going to plug it into g of x. So you need to plug it into the correct one based on the name. So this is saying f at 7. So if I look at f of x, do you see how it's 7? Oh, whoops, not 7. It's 2 times x. So 2 times 7 minus 1. So in place of the x, I put in the number they gave me. Again, two things that are butted up right next to each other are being multiplied.
Then we just solve one side.
And
we
then
solve both.
you don't solve both sides. You're just gonna, it's just a one-sided thing. It's just like that expression. But we need to use order of operations. So I multiply first and I get, and then after I get 14, I subtract 1 and I get 13. Okay. You can use a calculator for these two. -9. Ooh, this is actually kind of a tricky one. When you plug it in for g of x, first of all, I had to plug it into g of x and not f of x, right? See the g out front? The second thing you need to be careful of is to put parentheses around it, otherwise your calculator won't square it correctly. So on your calculator, if you do -9 squared, it's going to tell you it's -81. Because it's going to square the 9, and then it's going to reattach the negative. So this is on your calculator, this is what would happen. So you need to make sure, oh my goodness me, I'm breaking mud today. You need to make sure you put parentheses around it, because what do we know the true number actually is, or result? 81. So that actually squares the entire thing. So make sure you put parentheses if you're using a calculator. Okay, so going back to this problem, it's going to be 81 plus 5, which is 86. Again, using order of operations, exponents first. Okay. That pencil's dead to me. Broken my lab one too many times. I'm switching to pen, despite it being there. Alright, good for that one? Okay, let's try C. C is asking me to plug 2 in where? To the f of x. So it's going to be 2 times 2 minus 1. Follow order of operations, what do I get? 3. Now the last one's a little different. It's asking me to find g at 3, and then after I do that, it wants me to add 10 to it. So I've kind of got like two things on my to-do list here. So let's find g at 3 first. If I plug in 3, I get 3 squared plus 5. Well, what is 3 squared plus 5? 14. And then it wants me to add 10 more on top of that. So 24 should be my final answer there. So if you come across a problem like this, it's asking you to still evaluate, and then it might be asking you to add 10 more, or double it, or subtract 15. Who knows what, each question will be a little different. How do we feel, okay? Okay, so you have homework tonight. We're on assignment number 2, page 163 to 164, 1 to 13, 16 to 18, and 28. There is, oh, you can't see that, there you go. There is graph paper in the back if you need it for anything. It should be on my back shelf back there if that's something that would be helpful to you. And that's it.